IDEX that needs to be enclosed before I progress further. So I thought I'd do a little walk around while everything's still out in the open and easy to get to. This started out as a Voron 1.8 250 millimeter build volume. I built it as a test rig. I have a 2.4 I built by the book, and I didn't make any modifications, which isn't really my nature, but I wanted to have the 2.4 completely stock, working good, and then if I mess something up on this by fiddling with it, oh well, I've still got the 2.4 to use. So started with the 1.8 frame, took out all the center sections, and replaced them with 470 millimeter wide sections, which is the same width as the 350 millimeter build Vorons. I'm still coming up about 12 millimeters short on getting the full 250 millimeter travel. There's probably a little bit of room to play with the limit switches, and maybe we can do something to narrow the tool heads or something in the future. But for now, for testing, it's fine. I was inspired to try the IDEX after seeing Eddie the Engineer's videos showing it was possible, even if it's not optimized in Klipper or definitely not perfected. But I wanted to stick with the original stock Klipper build for now to see how far I could take it before moving on to any alternative forks. On Eddie the Engineer's GitHub page, his bill of materials calls for an MCU that can handle 7 steppers, but he's using CAN bus for the extruders, so you actually need 9 steppers if you're not using CAN bus. I could get away with 8 on the Octopus with a 1.8 because it only has 2 ZAxis motors. So I figured I could get away with by either having only 2 ZAxis motors or running both Y motors off one driver. That and running both Y motors off one driver ended up not working so well. We'll get into that later. I did end up going ahead and doing the ZAxis conversion because I purchased a Big Tree Tick expansion board. Right there, that's what's running the ZDrive right now. That plugs in where your LCD monitor, your LCD screen would normally plug in. So it works fine with any board with those outputs. But do make sure you clear out your LCD settings, clear all your pin assignments out of your config file before you hook that up. And it just uses the same pins as the LCD would from the main board. It doesn't have any separate pin assignments of its own. And it ended up working. So that allowed me to add 3 extra driver boards to get away with still not having to use CAN bus yet. Like I said, originally I used, well, the Octopus board has an extra connector to run 2 Z motors off one driver board. So originally I used that to run the YDrives, both Y motors. And that seemed fine during the early testing, but once I got into printing taller items, at some point I would hear a thunk and it would sound like motors were fighting each other or a belt had skipped, and I'd get a diagonal layer shift. So after tightening belts and checking connections and doing a bunch of other stuff, eventually I ended up to moving the other Y motor over to its own stepper, and that resolved the layer shift problem. I do not have it set up as a separate homing with a separate limit switch. I just listed the same limit switch in both places, and Klipper didn't yell at me for it, which was good. So we're still only using the limit switch from one side. Eventually, we'll get into gantry squaring and all that, but I want to get it printing first. So when I started on this, building off Eddie the engineer's work on his GitHub page. And in his videos, he mentioned that, you know, the belt clearances weren't quite where they needed to be, but for testing purposes, it was okay. But you, in my opinion anyway, you wouldn't want to run a printer long term like that. So the first thing I did was try and get the belt clearances squared away. So to make sure the belts weren't touching the mounting screws for the carriages, I just, you know, took this carriage off, installed the screws, and then I could see if, you know, the bottom belt was clearing those screws, and it had plenty of room. It wasn't nearly as close as it looks if you look at the carriage itself and the mounting hole. There's plenty of room. And then put that carriage back on, took the other one off, looked to see how much clearance was there. That was good, but then the belts were still against the blocks. So the belt was pushed, rubbing against the front of the blocks, which may have had microscopic clearance, but not enough to be comfortable with. And also the belts were kind of angled. They were crisscrossed. They weren't exactly parallel to the rail, and they weren't aligned with each other exactly. So to correct for that, I ended up modifying these parts, and this is from the 1.8. So the Trident part could be different for all I know. So I just had to move these front idlers out 1 more millimeter, and that gave clearance. So this one moved out 1 millimeter, and the one on the other side on the top moved out 1 millimeter, and that gave 1 millimeter clearance in front of the blocks, and also aligned the belts. So that worked out good without a whole lot of work. So after doing that, I noticed that when the tool heads were right next to each other, I originally started out with Eddie the engineer's carriages, and the belts were just pushed against the blocks to hold them in place. But when they get close to each other, it looked like it was still possible that it might be rubbing where they're close to each other, and it, you know, that put the belt in an angle also. So I modified it to make this little channel where it goes in, and you can see you've got like a 1 millimeter strip there to bring it out and hold it out a little bit, but it's still held in place against the block. It just goes in and then makes a little turn inwards, and then is flat against the block. And then it was a matter of making sure the belt for the other X carriage had clearance to be able to pass through. And on Eddie's design, he had sloped it in on the front. That was okay for testing, but you know, I wanted to see how close the belt was and where it was touching, if it was touching. So you can see all directions the belt can be moved, so it's got enough clearance there. So those pass through each other. And the YDrive is covered in his videos. It's just the original Voron setup. The only difference is the carriages, and one tool head is attached to one belt, the other tool head is attached to the other belt. So that motor there is hooked to the top belt. It's controlling this carriage. When this carriage moves, that one doesn't. And this one here is connected to that motor. And the bottom belt, same deal. So you can see, you know, on an original Voron, if you were moving the tool head, the Y-axis would also move, but this is only controlling the 2 X-axes now. But if you push or pull this, they still want to converge or move away from each other. So there's probably something in the kinematics to either hold that steady or counteract it. So that's the X-axis. For the Y-axis, it's really anything you can do to move it back and forth. To see if this would work, and if I wanted to progress further on working on it, I had these leftover motors from Monoprice MP Mini Select, and they wouldn't fit up under here, and I didn't want to buy other motors. In Eddie's design, you know, they go up under here. But just to see if the concept would work, I just took a flat plate, mounted them right there, as simple as could be, and screwed something to retain the belt in the top of the original piece there. And the kinematics worked out. I was able to get it working in the firmware and get everything moving as it was supposed to, so I figured I'd progress and design something to flip the motors to the inside. And this piece still needs work. I didn't leave enough space for the pulleys and the spacers, and so this is kind of splayed out at the bottom. But I'm forging ahead for now, because it's not the way Voron design would do it, but I kind of just want to tinker. So this is what we're rolling with for now. And then the belt's just secured by being pressed against the block. And there's, you know, it's notched out. There's a place shaped to fit the belt in the notches. Didn't want to put the adjuster in the front, but couldn't figure out a better way to do it. So we just got a little block there holding the yoke. And the yoke holding the pulley is attached to this bolt, which tightens it. This is off higher up. It's off center from that because I already had a hole there. So I just used the hole I already had. And it works. It's not intrusive. It all fits inside the frame. If you don't have cable chain and stuff running over here, it's not really taking up space that was being used for anything else. And the limit switches for the Y, I snuck them in there as kind of an afterthought, but want to give some more thought into, you know, what the best way to be to guarantee we're going off good surfaces and actually squaring stuff up. You know, I would rather index off this rail, but then again, the back rail is not bolted to the frame. It's connected using the AB drives, so, you know, how square is it? So need to devise a way to make sure that's squared up. I got lucky with the kinematics testing the first time around. Might have had to flip a couple axes, work out the Y, but it was pretty much I just followed what Eddie had done and checked the direction on X1 or X, check the direction on X2 or X1, whichever way you want to call it. And then got the Y straightened out, and then during homing, originally you could hear the Y fighting, the Y motor fighting the other motors. So some combination of flipping things and flipping homing directions got it worked out. But then after I had everything worked out and I built these interior, I flipped the YDrive to the interior, I tried flipping this entire cross back bar. I've always wanted to have the motors together and separated from the heated enclosure and outside air blowing past them. So I flipped this back bar to get the motors on top here, and I just could not get the kinematics to work. I thought it would just be a matter of, you know, reversing things, flipping things, but no matter what I tried, the only way to get it to work with the motors like that, I would have either had to move the 0, coordinates to the back, or move the limit switch for Y to the front. So I ended up redoing everything, flipping it back over, and we're back to working. For the wiring for the tool heads, this is just something I thought I'd try, because I like tinkering. I like trying to find better solutions, or finding the best solution. So this is, I guess, chain flex control cable. Product line is CF9, 20 conductor, 24 gauge, which is small, but if you double them up for the hot end, it's enough. There's enough conductors in there. It's a bit stiffer than I anticipated, so I ended up having to have fairly big loops. And still, I would not, it's stiff enough, I would not trust this on a cheaper printer than a Voron as far as being rigid, because if it moves to the back, it's, in theory, well, not in theory, in practice, enough pressure here and it could move the tool head around and throw things off. But for now, this is what we're rolling with. I have a big Tree Tech CAN bus set up, but that's another layer of complexity I don't want to get into until I've got everything else working perfectly. So that's what we're using for now. And after the wires, I couldn't find a PCB setup I liked, and I didn't want to put PCB on the side because of clearance between the tool heads. So I ended up just designing this 3D printed part to bolt to the back of the motor, and it just has the connectors soldered on to the ends of the wires from the cable. The pins moved around super easy, so I ended up having to insert a connector to hold the pin centered while I soldered the wire on. Otherwise, the plastic in the back of the connector was so thin that the male pin would just get askew. I decided to, I've always wanted to incorporate the spool holders into the printer. I don't like how they seem like they're an afterthought on every printer. And I know spools don't all come in the same size, but most people are using 1 kilogram spools, and if you want big 5-pound spools from Keen Village Plastics or somewhere else, you can always have some kind of external holder and run them in, you know, if you're not using them as often. I originally planned on having them in the sides, to each side of the print bed. But when I realized there was enough room in the back, I figured that was better for now anyway. Because the tool heads won't be over top of them, and there can't be any filament dripping on them or anything. And this is just the regular Voron spool holder, bolted in place temporarily. Did shorten it a little bit because it was longer than it needed to be for any of my spools. So we'll see how that works out over time. The chamber heater, that's PTC heater. This is experimental. We're still early in the phases of that. It says 500 watts on it. Cheap Harbor Freight clamp meter says it's more like 360. It came with a thermal cutoff that was 150 degrees, and I thought that was a bit high for being surrounded by ABS plastic and such. So I used one of the leftover parts from building Vorons, 120 degrees thermal cutoff, not thermal cutoff, thermal fuse. Spooled that to the side. The side doesn't get as hot as the center, with the cooling fans running on it and such. So that seemed to be about where as hot as the sides were getting in my experiments I did with it. I put it inside the Voron 2.4 with no other heat source, with these two 50mm fans blowing through it. And it took about 10 minutes to get the enclosure of the 350mm Voron 2.4 up to 50 degrees. It took 10 minutes to get up to 50 degrees, and it wasn't going up very fast after that, so I don't think it would have gone up much more. But there was no other heat source. The bed wasn't on, nothing. So it probably wouldn't take that big of a heater if you just needed to raise the temperature of the enclosure 10 or 20 degrees. So for this, I installed the thermal fuse and got a temperature sensor there, thermistor, just screwed in place. It's what I could do cheap and quick. The way I have it set up in Klipper, originally I figured, well, the fans have to be on whenever the heater's on, but you don't want the fans turning off every time the heater cycles on or off. Originally I didn't want it controlled by software because it's failure mode, but we're still working through that. So the way I have it set up right now, the heater itself is linked to this sensor, which is reading chamber temperature. So that sensor dictates when the heater kicks on and off. The fans are set up as temperature fans in Klipper. They're hooked up to that sensor. So when that gets up to 40 degrees, the fans kick on, and then they stay on until the temperature goes back down. And I also have it set where if the power, or if there's a fault, Klipper craps out. If you've ever noticed, when Klipper craps out, the hot end fans will stay on. I've got these set the same way. They'll stay on. We still have to account for the fact that something might happen where the fans aren't on and the heater's on full blast. So I'm still working through that. And when it cycles on, it heats up to 120 degrees pretty fast. And then since the center's hotter, even after it's cut off, that heat will keep moving toward the outside. So the heat continues to rise. So got to get it in the enclosed so I can experiment with limiting the amount of power the heater's getting, just figuring out how that's going to work, if it's going to work. These fans seem to move enough air. I think they're 14 CFM each, so it's 28 total. Well, they seem to move enough air when I was experimenting with them in the open. Now that I've got it hooked up to this ductwork, not quite as sure, but we'll see. My theory on this is that the cold air will try and fall from the top, but will be deflected by the hot air rising off the bed, so it'll go to the back and sides. It'll come down the sides and get sucked in this little vent here. And then those fans will blow it back up through the heater and heat the chamber. That's the idea. We'll see how well it works. I guess I'll show the mess in the back. Keep in mind, this is a test rig. So I hate to cut any wire the exact length and then decide I want to move something 3 inches and have to run a new piece of wire. So for now, this is what we got. I'm still trying to figure out what kind of enclosure I want for the electronics. I'm looking for something pre-made, but not finding anything as cheap for low prices I want. So we're using pretty much, well, most inputs and outputs. We're working on it. So we got X1, X2, Y1, Y2, extruder 1, extruder 2, and then the 3 ZAxis motors are running off this signal. LED lights are running off the bed output. We got the extruder 1, extruder 2, bed, chamber heater. Hot end fan 1, part cooling fan 1, hot end fan 2, part cooling fan 2, chamber fan. I got one fan left, controllable fan left for the electronics, and then there's 2 always on fan options left. The limit switches, X1, X2, or might be vice versa, Y1, Y2. Y2 isn't being used yet. We'll work up to that. And then the Z. So I've got three limit switch places left, which I'll hook up buttons up to. Since I don't have a screen, I'll do an emergency stop, and the others will be linked to macros or something. Still using the induction sender on the for the bed leveling. I've seen people complain about not being able to get it to work with the sensor on the Octopus. In the instructions, if you're using a normally closed sensor that shows is normally closed, which is what's always been spec'd on the Vorons, then you need to add this resistor. And it says in the instructions what size, I forget what size it is, and it's just connected to the first and the last. I could have crimped it in when I crimped these connectors, crimped the legs to it. I had already had the connector on there before I read the instructions, so I ended up soldering it to the back of the board. But, you know, it could go on the tool head, could go anywhere in the path, just it's connecting that first and last one. And then the induction sensor works no problem, and you're not taking up any of your other limit switch inputs. Temperature sensors, thermistors, we're using all of them. Bed, hot end 1, hot end 2, chamber temperature, chamber heater temperature. And just cheap Arducam PiCam works well enough to keep an eye on the print. While we're talking about heating enclosure, this stuff is really cheap. Polyiso insulation. It's got silver foil on the opposite side. It's fire resistant. Offers a little bit of R value, so a little bit of insulation, fire resistance. It's cheap. It's like $13–14 a sheet for 1/2 inch. So yeah, even if you've got a cheap little printer that you just want to build a cardboard box or something for, this is about as cheap as a cardboard box. While I'm rambling on about heated enclosures, I really don't like the exhaust vent, or having an exhaust vent on the Vorons. As far as what you can do about the ABS smell, sealing everything up is probably the biggest thing. So completely close off that vent, just print a new piece that doesn't have the whole back fan assembly and all that on it. Because if you use the vent even with a filter, you're just pulling in cooler air from outside when you're pushing out your hot air through with the exhaust fan. My Voron 2.4 one mod I have done is I put a fridge, well, I closed off the vent and I put a fridge door on the front, just big one-piece door that seals all the way around. So nothing else made a big difference in the ABS smell. You still have the little holes around the bottom where the Z belts pass through. That's one thing I like about the Trident design, is can be sealed up better. And the bed's in the top where the heat is. It's loud because I was cranking up the voltages, the VREF voltage, trying to figure out that Y shift. I thought maybe the motors were getting starved. So I need to go back through them and correct them. But anyway, I just wanted to close with, I'm not sharing the STL files because I am just hacking this stuff together in Tinkercad. I would like to learn Fusion 360, but time-wise, I just haven't got around to it. And I can always get whatever I want done in Tinkercad because it's so easy. So someday, but the X-axis parts would probably be okay, but the Y-axis, there's a lot to be desired, and they're not done the way Voron Dev would do it. All these various parts in the back holding the cables and reverse Bowden tubes, those are just crap I printed real quick to get the stuff in here. Like I said, this is a test rig, so I'm not going to share the STL files, but I am going to make another video sharing all my Klipper config stuff. I'm not going to share the entire Klipper config because stuff like those ZDrive motors that are run on the expansion board that's plugged in where your LCD monitor is, that could really screw up somebody's system if they weren't. If there's a thing with the internet of stuff that isn't right getting passed around. So I'm just going to make a video and go over the relevant settings that were required to get IDEX working in Klipper, and we'll throw in the chamber heater and fans as well, because that took a couple tries to get working. I'm slicing with Cura, and well, a couple things I didn't anticipate. First, with Klipper, you can only specify one part fan in Klipper. So I'm using multi-pin, so it basically just treats both part fans as one. When one turns on, both turn on. I saw some workarounds, but like I don't want to go to that much trouble yet, or do a workaround and then something better be incorporated into the main release shortly thereafter, and then I've got to undo my workaround. So there's that, and then Cura, when it generates G-code for multiple tool heads, it will specify a tool head before your start code. So unless your printer's been homed recently, it will issue the TO command for the first tool head, and Klipper won't like that is calling a tool head when when the printer hasn't been homed, and will crap out. Your print won't print. So every time I generate something in Klipper, I've got to open the G-code file and delete that first toolhead switch, or move. I guess you could move it after the print start. So that's one issue that has to be manually done. And then the toolhead switch itself, the way Klipper is set up, maybe someone has worked this out. Like I said, I'm still using the main version of Klipper. I haven't tried any of the forks that are meant for IDEX, but you know, this tool head, when it's done, will slide over there before this tool head starts moving. You could save a lot of time if, while this tool head was moving over, this one was moving into place. I did not see a way to do that yet. And then what Klipper does, it will park this tool head, and when a tool head stops printing, Klipper will drop the temperature of the hot end down to whatever is set for the standby temperature in filament settings. So if that's fairly low, the next time that tool head's called up, even though that tool head is moved to the side, this one has to sit there until it's heated back up. So The trick is going to be in filament settings to figure out, what temperature that doesn't ooze, but it's still high enough that you don't have to wait for it to heat up between every tool change. Also, as has been said, there's no mirror mode, there's no duplication mode in Klipper. So a lot of this stuff is in there just well enough to get it to work, and it'll work for what I want it for, which is printing supports. So good enough for now, and the print will take a little longer because of the way the tool heads changes are made. So that's what you're getting for building it yourself and using Klipper versus something commercially available where they've got their own tweaked version of Cura or something. So I guess that's it for this video.